on Friday, after school, I am going to work through one of the practice exams. I've given you 2 practice exams and then a few auxiliary problems. So I'm going to work through one of the practice exams on Friday after school and video it, post that video. So if you can't be here, it's fine. You can watch the video of me working through one of the practice exams. Both practice exams I've given you worked out solutions for. So that I haven't just given you the answers, I've shown you all the work. So once I go through one of them on video, you ought to be able to figure out the second one because it's exactly the same kind of problems that I've given you as solutions. Okay, gang? So if you can stay Friday after school, that's great. If you can't, that's great. But the video will be posted. Alrighty? Now, today we are ready to look at our notes for section 4.2. So again, like I warned you last week, take really complete notes. I should have all the quizzes up here. I do, right? I did all the quizzes up here. Take really good notes because we're going to be in the middle of this, and then we go for 2 weeks of vacation, and then we come back, and I'm going to pick up right where I left off. So you need to be able to tell what was going on from your notes. And I think for this first section, it's going to be super simple for you. I've drawn a triangle. This is not one of your special triangles. This is some random right triangle. You'll have to take it later, Max. Do you have a pass?
No.
Where have you been?
The office with Fisher.
Okay. Well, sit down. Right now I need you taking notes. So this is just some random right triangle. You recognize it's not 30, 60, 90 or 45, 49, 45, 45, 90. It's just some triangle. And based on this picture, you're going to give me the values of all 6 trig functions. So this should be easy for you. And by the way, notice how I'm lining them up. I always do this. Why have I lined up sine across from cosecant? Because they're reciprocals. So once you tell me what the sine is, I'm just going to flip it over and that's going to be this answer. It's going to be real simple. Now, here's my angle. Okay? With regard to that angle, identify opposite, adjacent, and hypotenuse for me. Which is the opposite side? For this angle right here, the opposite side would be 2. The adjacent side would be 3. And of course, this one is the hypotenuse. So if I know my definitions, I know sine is opposite over hypotenuse. So that will be 2 over root 13, which automatically means the cosecant is root 13 over 2.
Yep.
Is that okay with everybody? All right, what about my cosine? What will my cosine be? So that will be 3 over root 13, which means my secant is root 13 over 3. And what about my tangent? 2 over 3, which means my cotangent is 3 over 2. Isn't that easy? So easy. All right, let's look at the next one. Can we do the next one? Now pay attention to where the angle is, because that's what makes, that's how you know what's what, by paying attention to where that angle is. Okay, so what are your thoughts? Anybody have figured out what the sine is? 5 over 13. Why is the sine 5 over 13? Because it's opposite over hypotenuse. And opposite is determined across from the angle in question. So this would be opposite over hypotenuse, right? Which automatically means your cosecant then is 13/5.
Is this from the final?
What's my cosine? 12 over 13. So the secant is 13/12. What's my tangent? 5 over 12. So my cotangent is 12/5. Easy, easy, easy.
Oh, this works.
Now, yes.
So when you give us like 45, 45, 90, and like you say like it's 1, 1, and root 2. So it can those numbers just change like that.
No, if it's a 45, 45, 90 triangle, that will always be the case. These triangles are not 45, 45, 90s. These are 37, 53, 90 or something. We can have zillions of different kinds of right triangles. They're just not special.
Okay.
All right, so speaking of zillions of kinds of right triangles, here's another one. What is different about this one? The directions are the same. We're doing exactly the same thing. What's different? I don't have this side. So I will use my Pythagorean Theorem, Derek. Very good. To find that third side. So what's that third side going to be?
10.
Square root of 10. If whoever said 4, oh my gosh. 1 squared plus 3 squared equals h squared.
Square 3.
So 1 plus 9 is h squared is 10, so it's the square root of 10, right? In order to fill in these blanks, you need all 3 sides. So if one of them's missing, you need to do the Pythagorean Theorem to figure it out. All right, so now I'm ready to go. This is my angle. So what's my sine?
3 over 10.
3 over root 10. Meaning my cosecant then is root 10 over 3.
Is it off if you did the symbol at the end for the abbreviation one?
What?
Is it off on the quiz if you didn't put the symbol at the end?
I don't know. I have to see. Cosine. What's the cosine?
Opposite over hypotenuse.
One. Cosine is not opposite over hypotenuse. Cosine is adjacent over hypotenuse, so it would be 1 over root 10, which means secant is root 10 over 1, or just plain old root 10. What's my tangent?
3.
3 over 1, or 3, which means my cotangent then is 1/3.
If they are able to be reduced.
Always reduce them, yep. Always reduce if they're able to be reduced. All right, one more of these, and then we're gonna do something kind of the same, different kind of problem. Here we go.
We're just go backwards.
Do we have a missing side?
Root 21.
We have a missing side, and Brittany has said 2 squared plus b squared equals 5 squared. So 4 plus b squared equals 25. B squared is 21. So she said root 21 for that missing leg, and I think she's right. Got it? Zach, you okay today? You sick? Have you not been eating correctly? I know. And I hate it when they are zombies because they can't have appropriate nutrients. All right, here we go. What's the sine? Here's your angle. Pay attention to that. What's your sine? Root 21 over 5. Meaning the cosecant is 5 over root 21.
Yep.
What's my cosine? Cosine is 2/5. Meaning the secant is 5/2. Tangent, root 21 over 2. So the cotangent is 2 over root 21. How do you feel about those kinds of problems? Pretty good?
Beautiful.
Yeah, it's pretty easy. Just remember, if one side of the triangle is missing, you need to do the Pythagorean Theorem to figure it out. Now, the next set of problems looks like the same thing. The difference is they didn't give me a triangle. Now, I have one drawn there for you because I want you to get in the habit of drawing your triangles like this when you have to draw it. Yeah, now, if they draw it for you, you got to go with their picture. But if you're creating your own picture, let's get in the habit of drawing it like this, okay? This is part of what we fondly refer to as the butterfly bow tie. So as we proceed through the chapter, our triangles will always be one of these. So here I go. Here's this guy right here. I just drew him right here. Now all they told me was that the sine is 2/3. Now that automatically means the cosecant is 3/2. But how am I going to go about finding all the rest of the things I need to find? Jack?
So sine is opposite over hypotenuse.
So, oh my gosh, I didn't tell you where theta was. I need to know that. Anybody want to guess where theta is? Always at the origin. When you draw your own triangle, okay? When you draw your own triangle, theta is always at the origin. Always. If they draw you another triangle for you, then you got to go with whatever they drew. But if you're drawing your own, it's at the origin. So Jack said sine is opposite over hypotenuse. Right? Now I'm right back to where I was a minute ago. I'm missing a side.
It's root 5.
So I'll do the Pythagorean Theorem. So b squared plus 2 squared is 3 squared. So b squared plus 4 is 9. B squared is 5. So as Brittany pointed out, it's root 5?
Yeah.
So what's my cosine? Root 5 over 3. Secant, 3 over root 5. What's my tangent?
2/5.
No. 2 over root 5, that's not 2/5, it's 2 over root 5.
That's what I meant.
And the cotangent is root 5 over 2. Easy points, don't you think?
Yeah.
Easy points.
Are we taking a test this week?
We might have one more quiz.
Yes, yes.
Let's go.
Yes, keep them coming.
Yeah, because I caused that.
Yeah, it's not because of you.
Gotta see how far I get here. Okay, so now I'm on B.
Prayer.
Now I'm on B.
What?
So I'm going to draw my picture. Here's my theta. And this time I know the cotangent is 1/4. Right? So I'm going to automatically fill in the tangent is 4 over 1, 4. Now how am I going to figure out all the rest of that? Opposite over adjacent. Opposite over adjacent will be 4 over 1.
Root 17.
So then I do my Pythagorean Theorem, 1 squared plus 4 squared. She said root 17. Everybody got that? 1 plus 16. Now you can fill them in. Sine is
4 over root 17.
cosine is now. Some of you are frantically just scribbling all this down. Are you getting it? Can you find those numbers on your own? You got that? You okay with that? Okay, because now I'm going to have a couple volunteers
It's like
come
takes
up
me a
and
minute
do
to. I'll come up.
C and D.
Like on my quiz board, I need more slides.
I didn't even draw a triangle in this one. So yes, we are now getting to be big people. We're going to draw our own
I'll
triangle.
come up.
All right, Hugh.
Let me
I'll
do
do
the
the other
second one.
You
You've
got
got
tiger?
C,
Come on,
and
now.
Walter.
That's
Walter is going to do D.
What's her hair?
What?
And the rest of you are going to do it also. Okay, let's go, Hugh and Walter. Let's go. Come on.
What? He's a dog.
Wait, you don't get numbers there?
Trying to do that.
Oh, no, there's numbers. Where?
Yep, there's numbers.
The Ole Miss people are saying that.
Because the folks.
Wow. So here they go, and you are, you're doing C. You have to fill in your numbers.
The people are saying that they only like the second.
Hey, Sam, you got this done?
Yes.
C and D both? Okay, do it. That's your C. You're doing it. They're doing it at the board so you can watch and learn.
I did that first. Yeah, I got dry skin, so I was done.
Oh my, Walter's done already.
Figure it out, Hugh.
Okay.
Doesn't need to know what that is.
You do need to know what that is, Hugh, and you need to figure it out with your Pythagorean Theorem.
Oh no.
A squared plus
Call
5.
it something, even a variable name, whatever you want to call it.
A squared plus
A,
5.
alright, so A squared plus root 5 squared, root 5 squared,
They cancel each other out.
equals 3 squared. A squared plus B squared equals C squared.
Why?
A squared,
Why do you want
write
to
down A squared. What is root 5 squared? What's the square root of 9? So the square root of 9 squared is 9. What's the square root of 5 squared? 5. Yeah, so plus 5 equals
I heard he was. They got it, yeah.
3 squared.
You see that?
Well, what's 3 squared?
You see that? There's a step.
So right 9.
Wait, why
You're
is
solving for that, so
3A?
subtract 5.
No, he goes right now.
He's going to IU.
Yeah, he's wrestling there.
He's wrestling
Wait, that says A squared is 4. You have square root of 4.
Yeah, you got 4 release.
What's the square root of 4?
Wait, why is 3A? If it's the hypotenuse.
That's A squared.
But I thought the hypotenuse was C.
It is.
You're not going to IU next.
A squared plus B squared equals C squared. A squared plus B squared
Yeah.
equals
So
C
where's the
squared.
9 squared come in?
He doesn't have 9 squared, that's A squared.
Oh, that makes, oh my gosh.
Bro, what?
That makes more sense.
I'm going to USC. Out Cali.
Alright, here we go.
He's going to IU for bridge.
Okay, none of you are going anywhere if you don't pass this class. So right now, I'm going to pass this right here. Alright, so Hugh did his Pythagorean Theorem to find out this side was root 5. And then he just did all his definitions, and it looks pretty good. Walter did the same thing. He used the Pythagorean Theorem, and his looks pretty good too. Now, something like this that's 4/1, feel free to write that as 4. And this one, feel free to write as just plain root 17, right? Other than that, it's absolutely beautiful.
So they already give you the square root number, you can figure out the other two if you just like.
No, if they give you 2 of the numbers, you can figure out the third one. They really have to give you 2. Yeah, in order for you to find them the third one. All right. Now we are getting to number 3, which is the part of the first part of this chapter. This is a skill, it's easy, but it's one that we have got to get down because we're going to use it in lots of different kinds of problems. All right, so here we go. The sine of pi over 6. You are going to tell me, you are going to figure out the sine of pi over 6 without using a calculator. Okay? Now listen. So the first thing I want you to do is think back to what we did the other day.
180.
This is a radian measure. I want you to try to think about it for a minute in terms of degrees. Pi is 180, remember that? Oh my gosh, don't forget that. Pi radians is 180 degrees. So that's 180. But it's being divided by 6. So this is really how many degrees? 30. This is the sine of 30. You are being asked to find the sine of 30 degrees. Let me back up in case you weren't paying attention the other day. Pi radians is 180 degrees. This is a sixth of that. A sixth of 180 is 30, right? Now we're going to draw a triangle. And we're going to draw it the way Mrs. Ford told us to draw it when we're on our own.
Wait, the 30-degree angle.
And right here at the origin is going to be a 30-degree angle. Because the angle in question is always at the origin if you are drawing the picture. Now if that's 30 and that's 90, then this has got to be 60, right? And the sides of the triangle, we know those.
We do this.
So this
We
would
do
be
that.
a 1, this would be a root 3,
We
and
do
this
that.
would be a 2.
We're doing that at BC.
Now I want the sine of 30. So I got to remember sine is opposite over hypotenuse. So the answer to the question is 1/2.
Fascinating.
So that uses a ton of the skills that we've gained in this chapter.
So easy though.
It is easy.
Well, those numbers are really like now, like a number like 36 or 45.
It has to be a special triangle if you're going to do it without a calculator.
So all of these are going to be special triangles
Yep.
though.
No.
Yeah.
We're gonna be 45.
This one's gonna be like 6
Alright,
minutes.
so here we go.
That's a special triangle.
Now we're finding the tangent of pi over 4.
This is 45.
Okay, now, what is pi? Pi radians is the same as 180. So this is divided by 4. So 180 divided by 4 is 45 degrees. So now we're going to find the tangent of 45 degrees. So we're going to draw our triangle just like I told you to draw it.
Special, right?
You're going to put 45 right here at the origin because you always put the angle in the problem at the origin. If that one's 45, this one's 45.
90.
So we have a 1, and a root 2. I want the tangent of this angle right here. So that would be opposite over adjacent. 1 over 1 is 1.
What? Oh, so they're both special triangles.
Secant, pi over 3. Alright, so what are you thinking first?
60.
You're thinking pi is 180. So 180 over 3 would be 60. So we got the secant. I know you're excited by this. It makes me happy too, but one step at a time. This is the secant of 60. So I'm going to draw my triangle right here at the origin. And there's my 60. Right, James Cobb? Now I can label the sides of the triangle. That's a 30 there. So this would be 1, 2, root 3. Am I right?
Yeah.
All right, now wait, what's secant? Secant is the reciprocal of the cosine.
Yeah.
Cosine is adjacent over hypotenuse. So this will be hypotenuse over adjacent.
2 over 1.
So hypotenuse over adjacent will be 2 over 1 or 2. Kids, do you understand now why I made you memorize that pink sheet?
Yes.
If
that
you
pink sheet is
know the
everything.
stuff on the pink sheet, this is easy. This is just putting it all together. All right, cotangent, pi over 6.
Can't wait till you get shoot. That's hard.
Cotangent,
I even like this enough.
pi over 6.
You are
30. 30.
That's a 30. And the reason we know that it's 30 is because 180 divided by 6 is 30. So I need to draw my 30. I know that's 60. I know the sides are 1 root 3, 2.
So Jason over.
I want cotangent, which is indeed adjacent over opposite.
So root 3.
So root 3 over 1 or just root 3.
We need so much time for a quiz like this. It takes like 4 minutes.
Okay.
Actually, that's
So now what I want you to do is there's 2 more of these, E and F. I want you to see if you can do E and F.
Give me some time.
I'm going to give you plenty of time.
Yes.
So right now I want everybody doing E and F. Okay? So you two, Marquise and Zach, are doing E and F. You're not taking very good notes, honey.
No.
This is not going to be good.
I just didn't do
I need you to do E
I
and
think
F.
I know.
Walter?
You do it on the board.
Huh?
You do it on the board.
Walter is an animal when it comes to
Heck, I'll do
All
this.
right, Walter.
let me do it on the board.
Let's do it on the board.
Walter's going to do cosecant pi over 4.
I'll do it.
All right, Zach, you can do cosine pi over 3. All right, so here we go. Everybody's working on this. You have to figure out what the angle is. Pi is 180. What's 180 divided by 4?
There's so many things you have to know for these problems.
So we're always going to have a 90. Because look at the kind of triangle you're drawing. It's always got a 90. So if you're telling me one of them's 45, the other one has to be 45.
Anything you find is always going to be on the, is always going to make the data.
That's the order. Yep, that's
See, I'm like
gonna
him,
be
like I
your
said.
thing. Yep.
Who did the first one?
Piece.
Who did that one? I didn't know.
How do you get what?
Sharper.
No, I do.
Thank
I'm like him, like I know what I'm doing, but like at the same time, I have to do it so slow.
I don't know. We're gonna find out. We're gonna let the class vote. Okay, was Walter right? Walter's job was to find the cosecant of pi over 4. So let's walk through the steps. Step 1, figure out what this angle is. So 180 divided by 4, that's 45, right? So there's his 45. When you draw the triangle, that 90, you're going to always have a right triangle there. That's going to be 90. So as soon as he knew that one was 45, that one has to be 45. So he said, okay, the sides of my triangle are 1, 1, root 2. Then he said, all right, I need cosecant. Cosecant is reciprocal of sine. So it would be hypotenuse over opposite. He's right. It's root 2 over 1.
Root 3.
Root 3 over 2.
You're fine.
Adjacent over hypotenuse.
All right, we ready to look at this one now? All right. First step. Pi is 180. 180 divided by 3 is 60. So here's his 60-degree triangle. And again, this is always going to be a 90. Because when you draw your triangle, you are drawing it like that every time. Those of you that like things to always be exactly the same, this is for you. Because it's exactly the same every time.
Is it really?
The angle at the origin is 60. Which automatically means that one has to be 30.
I'm straight now.
So he is setting up his triangle, so 30 goes with 1. Yeah, he's got the triangle drawn perfectly. He wants the cosine, which is adjacent over hypotenuse. I don't know what he was messing around for. The answer is 1/2, right?
What was square root 2?
Adjacent over hypotenuse.
How did I put
All right. One more thing we have to do today. We need to get our calculators out. Mrs. Ford keeps saying you need a calculator every day. And as you keep postponing and postponing and postponing, you're just making your life harder. We need to have a calculator every day. Now, I want you to look at part 4. This is the last thing we have to do today. Or I should say, last thing we get to do today. Number 4. Notice that some of the angles have degree marks and some of them don't. That means some of these angles are in degrees and some of them are in radians. Okay, that's all right. But when I'm typing it into my calculator, I have to tell him what kind of angle I'm giving him. All right? So here's what we're going to do. We're going to go to mode, and we're going to make sure that degrees is highlighted. So mode is right up here in the top row. Press mode, and then make sure degrees is highlighted. We're going to go through, and we're going to do all of the degree problems first. Then I'm going to change my calculator into radians and do all of the radian problems. That way I won't have to be constantly switching back and forth. Okay, so we're going to do all the degree problems. Let's circle those. Which problems in this set are the degree problems?
C.
A is a degree problem. C, E, F, I, and J.
You say E?
So the degree problems are A, C, E, F, I, and J. Now, here comes the great mystery. How do I know they're degree problems? Because I see a degree symbol, right?
Wow.
Yeah. All right, so here we go. I am going to press, oh shoot, secant. I paid $100 for this calculator, and I do not have a secant button. No, there is no button. Don't press cosine -1. No, that's something different. If you want a secant, you got to remember your pink sheet. What is secant?
Cosine.
Reciprocal of cosine. So you are literally going to press 1 divided by cosine 10. Remember that secant is the reciprocal of the cosine. So when you have to type in a secant, you got to type it in 1 divided by cosine. So the answer that you should get, doesn't tell me how to round it off, the answer that you should get is 1.0154. Somebody else get that that's typing in with me?
Yeah.
1 divided by cosine 10. All right, now C. Well, I have a tangent button, so I'm going to press it. Do you remember from the other day how we handle the 28 degrees 11 minutes?
Yeah.
We press 28. Well, first press tangent. Press tangent. Did you press tangent?
Yeah.
Then press 28. Then we go into second angle. And remember, angle is the apps button. Degrees.
Close.
And then 11. Second angle. Minutes. And your answer to the second one should be 0.5358. So if you have forgotten how to do that, you're going to need to see me. Because we went through all that, how to type that in on our calculator, get those degrees and minutes. All right, but we get more practice here. All right, so if you were struggling with C, you're just going to have to stop a minute, and I'm going to show you, we're going to walk through E. E is the same thing. Okay, here we go with E. Shoot, E is a cotangent. I don't have a cotangent button. There is no button I can press that will give me a cotangent. So what am I going to have to do?
1 divided by 10.
Exactly. 1 divided by tangent. You get a cotangent by doing 1 divided by tangent. Now I'll put in my 13 second angle degrees, 19 second angle minutes. And the answer to that one, E, is 4.2248. All right? You can get negative answers. You shouldn't have gotten a negative for F.
I got negative for I.
Yep, you will get a negative for I, but not for F. All right, so F. Press sine. 127 second angle degrees. 18 second angle minutes.
Alpha.
Who remembers how to get the seconds? This is the weird one. Alpha plus sine. The answer to F is 0.7954. I is another cotangent. How do I get cotangent on my calculator? 1 divided by tangent. 158 second angle degrees. 19 second angle minutes. And as Brittany said, that is a negative number. So I is negative 2.5150. And the last one, tangent 300 second angle degrees, 18 second angle minutes, negative 1.7113. Now we're not done, we still have to do the radian ones. You got what? Did you type in 1 divided by tangent?
Yeah.
158 degrees, 19 minutes? Okay, you're wrong. I don't know what happened. Yeah. Type it in again.
Get any Christmas plans this year?
Yeah, I don't know. You type it in again. All right, now the other 4 problems that are left are radian problems. So in order to type those in, we have to go back to mode and change to radians. Make sure radians is highlighted. Listen, this is one of those things that is so simple, but it can be deadly if you don't pay attention. If your calculator is set in radians and you are doing a problem in degrees, you will not get the right answer, and vice versa. So you need to make sure that if you are being asked to do a radian angle, which we are, the last 4 are in radians, we want to make sure that our calculator is in radians. All right, so it is. So I'm ready to go. So I'm going to do B. My calculator's set in radians. So I'm going to type cosine pi, and I'm going to use the pi button, which is right underneath clear. Right underneath the clear button is the pi button. So I'm going to do cosine pi divided by 9. And the answer to B is 0.9397. When you are doing a radian angle, you literally type in exactly what it says. So it says pi over 9, so I type pi over 9. Now, how about D? 1 over sine. 1 divided by sine, 5 pi divided by 16.
1.799.
No. 1 divided by sine, that's how we get our cosecant. And then we do 5 pi divided by 16, and that's question D. And the answer is 1.2027. G, how do I type in a secant?
1 divided by cosine.
1 divided by cosine, perfect. And then 18 pi divided by 23. Negative 1.2891.
18 pi. Negative 1.098.
Okay, the right answers are up there on the board so far. I have not yet done H. How am I going to do H? 1 divided by sine, 2, just 2. And that is 1.0998. How did I know?
I got a different answer. 1 divided by sine, 2.
Uh-huh.
I got a way different answer.
I got that.
Yeah, I don't know. Because you're not in radians. I told you you gotta be in radians. Now, how did I know that number 2 was a radian measure? It doesn't have a pi or anything on it. How did I know that was a radian measure? It doesn't have a degree. Kids, if it's a degree problem, it will have a degree mark. If there's no degree mark, then you know you're going to do it in radians, right?
So it goes degree, minutes, seconds.
Now, let me plan. Do I see you tomorrow?
No.
No.
It's over. I get a quiz.
No bueno.